An important reason why process quality matters has to do with the cost of finding and fixing defects. This pyramid shows a typical cost ratio of finding and fixing a requirements defect as you get out towards the field. Finding a requirements defect in the design stage costs 5 times as much as if you had fixed it in the requirements stage, 10 times as much in coding, 20 times in unit test, 50 times in system test, and it can cost 200 times more to fix a bug after it's escaped to the field in the maintenance phase than if you had just figured it out in the requirements phase and fixed it there. Bugs introduced later, such as a coding bug, similarly multiply out depending on how long it takes to fix them. That sets aside the cost in brand tarnish and other issues that can be a real problem if you ship bugs out to the field. If you have poor process, you're likely to be finding huge number of bugs in maintenance, where they're incredibly expensive to fix. If you improve your process a bit, you can find them earlier and have better quality software at lower cost. Typically, if an organization has a lot of escapes to the field, they'll concentrate on testing first. Improving your testing process, and for example, using unit test as in addition to system test and acceptance test, can help reduce bugs. But testing isn't even looking at bugs until it's already really expensive to fix them. So that's nice to do, but you want to go further. To really have a good process that's producing high-quality software, you also need to do peer reviews back up front where it's cheap to find things and fix them. But those peer reviews only work if you're actually creating the artifacts to review. If you don't have a design, you can't peer review the design and find bugs at 5x instead of 200x. If your code's a mess because you're not doing static analysis and you're not following a style guide, then peer reviews are going to be much less effective at fixing bugs. The idea here is that you have to not only define this nice V process, but you actually have to follow it to be able to find the bugs early when they're cheap instead of late when they're expensive. And SQA is how you know whether or not things are working. SQA is how you know whether your process is actually being followed and whether it's being effective at finding problems when they're cheap and easy to fix instead of expensive.